In our previous video, we look into the general structure of the creating table as well as how to add the primary keys into the table. Today, we want to see how do we add the foreign key as well as other constraints onto the table that we want to generate. Of course, foreign key is one of the most important constraints that we are able to link the tables together. So let's take a look at this. For the foreign keys, you are able to define the foreign keys at the column level as well as the table level. Again, column level means that you can add the foreign keys when you are creating the column or the attributes. On the other side, you can also create the foreign keys after all of the columns are defined and then add the constraints to the table. One important thing I want to mention to you is that although both of them are possible, most of the times we do add the foreign keys at the table level, and I will talk about why pretty soon. The foreign key constraints is also known as the referential integrity constraints. It is used to link the two tables together. Of course, the foreign key indicating that for a table's foreign key links to another table's primary key. So it uses a column or columns as a foreign key, and it establishes a relationship with the primary key of the same or another table. Most of the time, we are looking at referencing another table's primary key. However, in a recursive relationship, we are referencing the same table's primary key. This is an important thing to understand. In order to establish a foreign key constraint, which means that when you adding the foreign key constraints onto the table, the other table you try to reference has to be exist already. If the table is not there, the foreign key command will be denied. This is a very important understanding, so that if you try to create a foreign key at the column level, which means that you try to define an attribute, it says that the other tables that you try to reference has to be there already. Not to mention the primary key has to be defined already. So it's kind of difficult to do that all the time. Foreign key and referential primary key columns don't need not to have the same name, so the name can be different. However, the domain has to be the same, and therefore a foreign key value must match the value in the parent table's primary key value or to be null. In other words, their data type need to be the same. The size has to be the same. That's the key thing for you to create a foreign key. So like I said, for both of the foreign key definitions can be added at the column level as well as at the table level. So if that's going to be defined at the column level, let's take a look at that. At the column level, indicating that you try to create the faculty ID as the attribute, you try to define the data type with the size of that, and then don't forget to add the constraint as a reserved word, and then put the constraint name. The name is defined as the way of the table, attribute, and then abbreviation of the constraint you want to add linked through the underline, so that we will be able to give a name to this constraint. And remember, this is only the name. The instruction given to the computer as follows. So for the computer to understand that you want to create a foreign key, you have to give the reserved word foreign key with a parenthesis indicating which attribute that you want to use to create a foreign key. And then the reserved word references S needs to be there as well, because this is the whole reserved word. With another table, another table's primary key. So you can see that foreign key definition is probably one of the most complicated one, because again, you need to talk about what foreign key in this table want to reference another table's primary key. And therefore, this is how we will be able to create a foreign key at the column level. Needless to say, when you try to execute this code, the faculty table has to be there already, as well as the faculty ID as the primary key need to be defined already. If you want to define the foreign key at the table level, basically it's the same. You are going to still basically copy and paste all the words after the constraint. So you will constrain with the name of the constraint, foreign key as a reserved word, parenthesis, faculty ID indicating which attribute you want it to be a foreign key, reference another table's primary key. Again, the faculty as well as the faculty ID has to be exist already. Therefore, let's take a look at this. Why I said, although you are able to create a foreign key in both column level as well as the table level, you usually want to define that at the table level. Here's the reason. So if you look into this relational schema diagram, you would understand that there are 1, 2, 3, 4, 5, 6, 7, 8 foreign keys, and therefore there should have 8 foreign key constraints be added to complete this table creation. And while you're creating a foreign key, the other table's primary key has to be there already, so that if you look into the next slides that I have underlined the red lines, you will notice this. When you try to create an employee table, there is a foreign key called DNO, try to reference department and department number as the primary key, and therefore you have to define employee after the department table. Because if you want to create this foreign key, department table need to be there. And when you try to create a department table, you will notice that MGRSSN also referencing the employee. In other words, employee need to be created before the department. And that forms a deadlock over there. None of the table can be created before the other one. So how can we solve this problem? In short, the way of solving this problem is that you create 1, 2, 3, 4, 5, 6 tables first without adding any foreign keys. In other words, when you try to create this relational schema diagram, and that can be also used in a strategy for your project, you create all the tables without paying attention to their foreign key first. And once you finish all the tables creation, now you have all the tables as well as all the primary keys, you can add the foreign key back to your design. And that is how we can solve the deadlock here. Let's take a look at this. When we try to create a table, we first of all create an employee table as well as the department table. And you may notice that when we're creating the two tables, we add only the primary key constraints over there. Of course, if you have other constraint, non-null constraint, check constraint, unique constraints, you can add it over there as well. But we intentionally leave the foreign key constraints out. And therefore, we will be able to create the two tables. And after the two tables are created, we can use the next important concept, which is called alter table. This again is a reserved word or a command in Oracle for you to add the constraints back to the table. So what you would do is that after the two tables are created, you will be able to say alter table, like indicating you want to alter the table by adding something, deleting something. And in this case, we can say alter table employee. Of course, you need to provide the table name indicating now which table you want to make the change. And of course, because we want to add the constraint, we will say add as the add constraint, and then the whole foreign key constraint need to be put over there. So you can see that the example code over here is add constraint with the name of the constraint foreign key indicating which attribute of the table you want to change references another table's primary key. This semicolon is the key thing. Oracle will keep let you type the commands until it sees a semicolon. This is like your Control F5 execute. So if you did not put this semicolon over here and you hit enter, so saying that we pretend we didn't see this semicolon and we hit enter, what's going on is that you will not see table altered. You will see a column 4 over there with a cursor blinking there, indicating that the Oracle is waiting for more instructions. So when you see that, if you see a row that's a new number comes out and the cursor is blinking over there, that's Oracle giving you a hint that it's waiting for a semicolon. So if you do that successfully, you will see table altered, indicating that the constraint has been added. And therefore, you can see that the way of creating those two red foreign keys is going to be in here. We will create a table first, and then create another table, and then we try to alter the table employee by adding the foreign key, and then add another foreign key to the department so that its manager social security number will reference employee's social security number. So that is how we will be able to create the foreign keys after the tables are created. I actually have this in the code together with today's lecture so that you can really practice. And I also want to show you how is this code being executed. One more thing that I want to mention in the file I provide you. So this is the whole copy and paste things that I have over here. Before we execute anything, you may notice that I do drop table employee, drop table department. Why do I do that? You need to understand one thing. Oracle remembers everything. So if you want to rerun a program, the Oracle is not going to let you create an employee table while it already have an employee table. So, and you may have these experiences in your assignments already. So how can we deal with that? We need to drop the table. So drop table is the reserved word for you to drop the table. Of course, you need to provide the table name. If you have never added the foreign keys before, drop table employee, drop table department is good enough. However, if the foreign keys are created, then it will give you an error message if you want to drop the employee table while department is referencing the employee table. So in order to make this drop table go smoothly, we need to introduce you another reserved word called cascade constraints. What I'm trying to say is that I know there is a foreign key that links the tables together, but I don't care. I really want to delete the table because I have my purposes. And this is going to be useful when you are creating the initial structure of the table so that you can rerun the program while you make modifications into your table creation. And therefore you can see that you have these codes over there to execute, and so that you will be able to create the two tables even if you have employee table as well as the department table in your programs already. And therefore that is the what this video want to show you. And what I want to do next is really run the program and then show you what's happening. As I mentioned, the test.sql attached to today's class is actually the file that we want to do. And if we open up the Oracle and then try to run the program, then what we will see is that we will be able to run the Oracle Express Edition and run the command line. And when the command line pops up, what we want to do is we want to connect system and then type in the password. Again, the password is not when you type in the password, the cursor is not moving. Don't panic, just keep typing your password and it will work. Now, since we already have the file and I already have stored that in under the C folder, I create a temp folder for that. And then the test.sql is over here. One important thing for you to understand is that in order to see the full name of your file, and of course you need the full name of the file so that you can tell the computer to execute it, you need to go to the view and then check the file name extensions so that you can see the full file. If you uncheck it, sometimes it ends up with .txt or something, and if you do not provide the full name, the Oracle is not going to recognize that. And therefore, what you will need to do over here is going to use the @ sign indicating you want to execute the code, provide the full link, and that's why I want you guys to go to C folder and then create temp folder, and so that you will be able to know where you store your files. And then give the full name of the file, test.sql over here, .sql over here, and then hit enter to execute the code. So what you will see is that it's actually have several informations showed you over there, and I want to go through line by line and let you understand what is going on. The first two things, the first two table drop, indicating that I try to drop the employee table, which I already have because I have the cascade constraints. I can drop those even though they are foreign keys linked up together. When I'm trying to drop another table, so you can see there are two tables dropped. And then I try to create a table employee as well as create a table of the department. That's why you see another two table created information over here. And then I'm trying to add the foreign keys back to the table, and that's why you see there are two table altered over here. And therefore, this is like the whole thing to teach you how to add the foreign keys onto the tables that you have created. Before I end this class, I want you guys to have some simple practice, and you don't need to submit this one. I'm not asking you to submit this one. I just want you to have a little bit of the practice. Since you already have the test.sql files and we have defined the two tables over here, you may notice that I did not create this foreign key, which is a recursive foreign keys, recursive relationship over here. So as a simple practice, help yourself create this foreign key into the test.sql and then try to see if it works, if it's not working. So what you need to do is basically go to the test.sql and then add another alter table informations over there, and you will be able to add the foreign key back to the employee table. That is all I want you guys to see for the foreign key constraints, and you will see other constraints in the following video.